Hey everyone. So, let's talk about times tables. That thing that so many of us, whether we were students or now we're parents, have struggled with. But what if I told you the whole goal isn't just about memorizing? Today we're going to dive into a totally different way to look at it. A toolkit for really understanding multiplication from the inside out. Let's get into it.
I want to kick things off with a pretty bold question here. What if we've been teaching multiplication all wrong? Seriously, what if all those drills, the flashcards, that feeling of anxiety, what if that was actually the least effective way to learn? And what if there's a much better way to build real mathematical confidence?
Okay, I want you to look at this number, 40%. Just let that hang in the air for a second. What on earth could that 40% possibly have to do with multiplication?
Well, that's the performance boost. Yeah. Research shows that students who learn the why behind multiplication, the concepts, they actually outperform students who just memorize the facts by a huge 40% on reasoning tests. See, this isn't just about getting the right answer. It's about truly getting the math.
And that brings us to something I bet a lot of you remember, the times tables nightmare. You know, that constant pressure to just spit out facts as fast as you can? It usually just leads to a lot of anxiety and honestly, a pretty shallow understanding of what's even going on.
And you know what? There's a scientific reason why that old method just doesn't work for so many people. It's not because you didn't try hard enough, it's literally about how our brains are wired. So let's take a look at the actual science of forgetting.
It all boils down to this thing called cognitive load theory. So, think of your working memory as like a little desk. If you just pile that desk high with 144 random facts, well, you've got no space left to do any actual work. But learning the concepts first, that's like tidying up the desk, leaving you plenty of room to actually solve problems.
So this leaves us with a really clear choice. On one side, you've got rote memorization, and that path is pretty much paved with anxiety, superficial learning, and, you guessed it, forgetting. But on the other side, you have conceptual learning, which builds confidence, deep understanding, and, most importantly, it sticks with you. The better path seems pretty obvious, right?
So, the big question is, how do we get on that better path? Well, the very first key is to stop thinking of the times tables as 144 separate things to memorize and start seeing the beautiful mathematical patterns that are hiding right there in plain sight.
And it all starts with this one simple idea that is actually super profound. It's called the commutative property. Basically, 8 times 7 is the exact same thing as 7 times 8. The moment a kid really truly gets that, boom, their workload is nearly cut in half. And it's not a trick, it's a massive confidence booster.
And the patterns just keep coming. I mean, the 2s are always just even numbers. The 5s always end in a 0 or a 5. That's easy. And here's a fun one for the 9s. The digits in the answer always add up to 9. Think about it. 9 times 3 is 27, and 2 plus 7 is 9. It works every time. These aren't shortcuts. They're the logic of the whole system.
Okay, so seeing the patterns is step one, but the next step is to take multiplication completely off the page and turn it into something that you can actually see and touch and feel. We've got to make it real.
And there are some really powerful ways to help you literally see the math. You could use the array method, where 4 times 6 just becomes 4 rows of 6 little objects, or you can draw it as a simple rectangle with the area model, or you could even hop along a number line, 4 jumps of 6 spaces. These aren't just little drawings. They make the whole concept come alive.
And it gets even cooler when you actually start to move the math. Research has shown that when you connect movement to learning, you create these incredibly strong memories. We're talking about things like clap and step patterns for the 2 times table, or even having a group of kids arrange themselves into a human grid. You're literally connecting the concept to your body.
Now, this whole modern approach isn't about getting rid of tools. Not at all. It's about using smarter tools instead of just working harder with the old ones. And that means using a mix of both physical and digital resources.
So the modern toolkit really has both. You've got physical tools like cues and air rods that let kids literally build and discover the patterns for themselves, but at the same time, you've got these amazing adaptive digital apps that can turn practice into a super engaging game with feedback tailored just for them. Both of these have a really important role to play. So how does all this stuff actually fit together? Well, it's a pretty clear sequence. First, you build that conceptual foundation with hands-on stuff. Then you move on to spotting patterns. It's only after that that you start strategic practice, which finally leads to fluency. See, memorization isn't the first thing you do. It's the natural result of everything else.
And that really brings us to the whole point of this.
The ultimate goal isn't just about being a speedy calculator. It's about something way deeper and honestly way more important. It's about confidence.
A key idea from our source material really says it all. The goal is mathematical fluency, not just memorization. And fluency doesn't just mean speed. It means you're flexible, you're efficient, you're accurate, because you actually understand the why, not just the what. And that is the foundation for a lifetime of success in math.
So, I'll just leave you with this one last thought. What if we stopped looking at the times tables as this scary hurdle we all have to get over, and we started seeing them as the very first and maybe the best opportunity to build a child's confidence and a real love for thinking like a mathematician? What if the key was right there, hiding in plain sight all along?